9.2 is rational and irrational numbers. So let's start with the rational. The rational is pronounced as ratio and null. So ratio is usually, ratio is 1:2, which means you compare two different objects. For one apple there is two mangoes, so it is 1:2 proportion. Okay, here when you say rational numbers, you are comparing two different languages that represents the same number. One is fraction and another is decimal. Always the fraction has its equivalent decimal because both are same numbers but different languages. So 1/2 is equivalent to 0.5. You call it rational because the ratio of two different languages they are equivalent. Always a decimal rational means the decimal number has its fractional equivalent. This is workable for all shapes except the diagonal of a right angled triangle. Not every triangle, the right angled triangle. Basically the right angled triangle has the diagonal as such, and for the circle they are called irrational numbers. For example, irrational numbers go on forever and they have no equivalent fraction. For that decimal for the irrational decimal there is no equivalent fraction. They have approximated fraction. The decimal is always matched with the fraction. They are all terminating or else they are recurring but in a pattern. Irrational numbers were discovered by Greeks accidentally. They tried to measure the diagonal of a square of 1 centimeter. Usually for 1 centimeter, the diagonal should either be 1 or should be 2, but when they measure, the diagonal is not 1 or not 2 or not any normal simple fraction related decimal. They kept checking but it did not match with any number they know in the fraction. That decimal number did not match with any known fraction. So they realized the diagonal is a new kind of a number for every measurement, because for 1 and 1 they found the diagonal is, when they measured using the scale, the diagonal was 1.41. They made a rope with knots for this measurement, and it is they not only measured for this one, when they measured 2, it was 2 times 1.4, and when they measured for 3, it is 3 times 1.4. So any side it is 1.4 times the side, but not exactly. The more carefully they measured, the more they saw it wasn't a simple fraction, the square house with wrong diagonal. So they wanted to find out the correct way to find out how this diagonal is coming without the trial and error method, because for these small things they can use trial and error method using the rope or the scale or any other measuring tool. But when the things becoming bigger and bigger, we cannot find trial and error method. So they wanted to find a perfect maths way. Because it's very important, a square house with wrong diagonal becomes a tilted rhombus. If you see the Pisa tower leaning, we are talking about only a square. Why am I talking about the buildings? Because the diagonals are mostly used to see if something fits through the door, like TV or a fridge. They are all in the cuboid or the cubic structure. So basically, when we want to find for a square, a 2D shape, we can measure the diagonal with the help of a tool like this diagonal. But when it comes to a cuboid like this or it is so hard because the inside space is hollow. So diagonal measurement using maths is very important than the trial and error method. And just now I said decimal is another language to talk about the same number, because in Tamil also we say 1 to 2, in English also we say any 1 and 2, but all means the same number. When you use a ruler, you don't say the line as 37 by 100 of a meter, you say 0.07 meters. These decimal is very important, the metric conversions, and the decimal match. It's always used in the metric conversions, and usually in the tools like ruler, measuring cups and money, decimals are used, not the fractions. The decimals make the money easier. It is 10 and 75 out of 100 rupees is what we say, or 10.75 rupees we say this. It also makes the calculation easier. For example, 7 by 20 plus 13 by 50 is easier, or 0.35 plus 0.26 easier. Of course the decimal is easier, so we always have two different numbers and we always see if they both are matching. If they both are matching, it is called the rational number. It is used to cut, for one example is to cutting pizza, using for division in general. And the irrational numbers are using for measuring the diagonals and calculating the area of the circle, which means pi. This diagonal is basically the roots, so they are used in the circles and diagonals. I said in circles irrational numbers are found because if you say 22 by 7, it is not an exact replica of 3.14. 22 by 7 is an approximation for 3.14. Therefore 3.14 is called as pi, which is approximated to the fraction 22.7, which is not exactly equal to 20. These two are not exactly equal. That's why this is considered as irrational number, irrational fraction. I just now said what is irrational numbers which don't have its equivalent. These are all decimals, especially it is used in the roots and the pi. In this 9.2 they are concentrating only on the diagonals, that is the roots. Okay, any root like cubic root, root to the power of 5, etc., anything, or sometimes 2 to the power of square root of 2, anything of this order comes as a irrational number. Also I said this irrational number was invented by Pythagoras. See, Babylonian found what is root 2, which is approximately, they rounded it off to 1.414213, which is equivalent to 6 decimal places 1000 years before the calculators were used. This was actually found in the Yale Babylonian collection, item number 7289. That is why in a clay, that is a clay tablet, that is why it is called YBC 7289. Because see, a wrong angle, a pyramid collapses. If you don't correctly measure the diagonal, the pyramid collapses. So they have done it before. When we saw, it is a tablet that has a drawing of a square using base of 60 system, like the clock 60, it has 60 minutes, right? And using the tedious effort, we don't know how they found, but we know they have found. Okay, the way we did not know, but later Pythagoras, a Greek, he found the diagonal is exactly measured using the square shape. The measure பண்ணனும்னா நீ வந்து always because see, if we draw a square or a rectangle, anything, okay, and if we have to separate it into two shapes, you get a right angle triangle. See, இங்க பார்த்தனா right angle triangle, the inside part is always a diagonal. இந்த diagonal hollow spaceல இருக்கும்போது நம்ம இத கண்டுபிடிக்கணும். இப்படின்னு தான் Pythagoras வந்து to find this exact diagonal, he said this diagonal or the side is obtained by using the square. The square of this two, by a square plus b square is equal to c square. This is for the square. What he found is for the square. But to find the line கண்டுபிடிக்கணும்னா they have to use square root. So any square root நம்ம வந்து அது வந்து irrational-ஆ தான் இருக்கும். If the square root is not if அதோட ஸ்கொயர் ரூட்டோட டெசிமல் கால்குலேட்டரில் டைப் பண்ணோன்னா அது பெருசாக போய்கிட்டே இருந்ததுன்னா இட்ஸ் irrational. அதே மாதிரி இப்போ பிகாஸ் Pythagoras found this diagonal, இந்த Pythagoras தியரம் யூஸ் பண்ணுற எல்லாமே, ஃபார் எக்ஸாம்பிள் Pythagoras தான் கண்டுபிடிச்சது இந்த sin theta to equate the circle and this diagonal. இதை வந்து இந்த மிஸ்மேட்சை வந்து Pythagoras வந்து பண்ணனதுனால Pythagoras கண்டுபிடிச்ச எல்லாமே like sin 1, cos 1, tan 1, when the angles is measured in radians. Okay, இது வந்து ஒரு radians, ஏன்னா இந்த நான் சொன்ன மாதிரி இவங்க வந்து ரேஸ், சன்னோட ரேஸ் யூஸ் பண்ணி தான் இந்த 60 system. So it is measured in radians. அதாவது வேர்ல்டையே வந்து ரேடியன்ஸாக தான் பிரிச்சிருப்பாங்க, 0 degree, 1 degree. ஸோ இதுலேருந்து 2360 degree வரைக்கும் பிரிச்சிருப்பாங்க. ஸோ when we measure in radians in the real life, it is going to be an irrational number because this combination, our circle and diagonal ரெண்டையுமே combine பண்ணி கண்டுபிடிச்ச this combination works with the Pythagoras theorem. So this is also an irrational number. Other irrational number includes circlesல வந்து pi எப்படி வந்ததோ, pi வந்து pi d, the area of circle is pi d. Okay, அதே மாதிரி see any square having a side a will have a diagonal of whose measurement will be a times square root of 2. அதே மாதிரி தான் any circle has an area. இது வந்து diagonal will be a times square root of 2. இப்போ இது ஒரு ஸ்கொயர்னு வச்சுக்கோ. Pretend that this is a square of all the sides a அப்படின்னா this diagonal will be a square root of 2. இது வந்து a is equal to 5 இருந்தாலும் சரி, a is equal to 50 இருந்தாலும் சரி, எதுவாக இருந்தாலும் இப்போ 50 இருந்ததுன்னா it will be 50 times square root of 2. இது வந்து ஸ்டாண்டர்ட். இதுதான் பித்தாகரஸ் கண்டுபிடிச்சி. இதுவும் சரி any circle it will be pi into d will be the area. So Pythagoras, so the irrational numbers goes with the area of the circle related things, basically pi related things and its extension. அது மட்டும் இல்லாமல் Euler's constant இல்லாமல் இந்த மாதிரி constants e to the power of pi, ln to ln to இதெல்லாம் எனக்கு தெரியல, but anything like this will be irrational numbers. All the other things comes in the rational numbers. See, irrational number is used for two shapes. One is for the right angled triangle, another one is for circle. Adila specially நீ இந்த வருஷம் you 9.3 you are talking about surds, which is only the roots, irrational roots. Surds are sure numbers, okay va? What is why am I saying surds la இந்த d மாத்தி போடுறேன்னா that is a sure number, but the sure number, the sure number is in the calculator. When you want its equivalent in the ruler, if there is a ruler is always, ruler shows simple numbers, that's why it cannot show the correct value in full. But square roots are real numbers, but rulers can only show the approximation, so you cannot see the exact square root value in decimal in full length on a ruler. Engineers use surds all the time. If an engineer builds a perfectly square room, each wall is 5 meters, the diagonal across the room is a square plus b square, so 5 square plus 5 square is equal to c square is 50 square. Then c is square root of 50, which is 5 times the square root of 2. So it's very important, especially when they are constructing a big mall or the spacecraft engineering or the bridges beam calculation. The diagonal of these structures tells them where to place the beam, how long the cable must be. If they rounded too early by using the ruler measurement, which is not exact of square root, or it is not going to give the exact diagonal length, the pieces might not fit, so they use 5 square root of 2 in the maths way. So surds avoid big mistakes, especially in malls and all these bridges beam calculations and the spacecraft engineering. And also in the computer generated answers, it not using the rulers for engineering and architecture and the physics forces calculation for spacecrafts, etc. Especially the distance between Earth and other planets will be very very high, and when this distance goes in the inverse for the calculations formula, it goes for many numbers, many digits, so the precise design is required, as no trial and error method is followed in spacecraft and all. We have to sit here and calculate so many things, so only math calculations is done. If you round too early using the ruler method, if you round too early in the sense you are cut down with 6 digits where the real answer requirement is 17 digits. Small errors adds up and final shape won't fit, so math keeps things exact with square roots or roots, basically roots. So builders use the approximations like the 1.41 etc. when the cutting materials or when the miscellaneous works. So surds are basically irrational roots, and surds are sure numbers, but its decimal equivalent is not found in the fraction. So roots that are not rational are called surds. There is a topic called rationalizing denominator. Irrational numbers are square roots and pi, and especially when the square roots appear in the denominator, you have to convert this square roots. Square roots are considered as irrational. This irrational number should be rationalized. So irrationalizing denominator, what is the need? See, usually we see 1 by 5 is like 1 out of 5 parts, and 2 by 6 is 2 out of 5 parts. When we have to add, we find the LCM for the denominator, not for the numerator, because the whole is the denominator. This is fractions, so we concentrate this part. This shaded part is already coming in the denominator. If you do for the denominator, it's enough. So same concept, making the denominator into the rational numbers. Also, if the denominator is a normal number, the calculations, see, the numerator and the denominator are quite simple. See, and if the denominator is an irrational number, the irrational equivalent is 1.732, and to convert into the whole numbers we have to multiply with this equivalent decimal components, so you get a big numerator and big denominator. This makes the calculations much harder, so we preferring to rationalizing the denominator. The next is sets. Sets is short and sweet symbols. மூணுமே S, short and sweet symbols are called sets. So basically a tidy way to show a collection of things is called sets. It's a technique like tally. Tally எப்படி ஒரு technique, அதே மாதிரி sets is a kind of, for example, there is a toy box having cars, balls, dolls. Set is a curly bracket with car, ball, toy அப்படின்னு நம்ம சொல்லுவோம். Sets are used in all the modern technology by engineers, architects and many professionals. Sets வந்து சிம்பிள்ஸாக இருக்கும். It goes hand in hand with Venn diagram. அது வந்து ஒரு circle representationாக இருக்கும். So basically this Venn diagram is overlapping condition. When teacher wants to use who is allowed and who is not allowed, they use Venn diagram. Even in the ancient period, pyramid constructions they have used. For example, set A is stone heavier than 2 tons. Set B from the limestones from quarry X. Set C is stone block with no cracks. Set D is blocks shaped for lower layers. So sets reduces the chaos and improves the planning and quality of construction. If they are looking for stones that is belonged to all the right group for starting, அதாவது lower sectionல start பண்ணணும்னா the limestone from quarryன்றதுலாம் important கிடையாது. ஸோ அந்த செட் எப்படி இருக்கும் for the pyramid constructionக்கு? A intersection C intersection D. So heavier than 2 tons, blocks with no cracks and blocks shaped for the lower layers. So இப்படி கரெக்டாக அவங்க செட் போட்டு எடுக்கலாம் than randomly choosing. See, this is a quick recap of the number system. As we are going to use the number system in so many problems in the sets, please learn this, it will be very helpful. You know the number system, capital N represents a natural person. நம்ம கையால் கவுண்ட் பண்ணக்கூடிய நம்பர்ஸ் எல்லாம் I'm a natural person, so they are called as natural numbers. For example, 1 2 3 4 5 6 negative 1லாம் வராது because we can't count negative 1 2 3 and all. Okay, so they come in Z, any negative numbers, the integers basically comes in the Z. And R அப்படின்னா real numbers. Real numbers, they are real, but you can't count it only with hand alone. This includes the natural numbers and the countable numbers and the non-countable numbers, fractions, decimals, everything comes under the real numbers. Real numbers includes everything. And Q is for the rational number and R divided by Q is for the irrational number. Q na you have an equivalent. See, Q na நம்ம எழுதும்போது there is an equal. Q வந்து இப்படி கட் ஆகும்போது example, this is a fraction, this is a decimal னு வச்சுக்கோ. They both have an equivalent அப்படின்றதுனால தான் இந்த Q shape choose பண்ணியிருப்பாங்க. So it is rational fraction, rational decimal, அதோட equal and decimal, everything comes in 2. அதே சமயம் R divided by Q, அந்த Q வந்து கீழே தள்ளப்பட்டு விட்டது, அதாவது it's irrational. Any irrational fraction or decimal comes in R. In the R divided by Q, in the Q, Z, N, everything comes in real, but only countable things comes in natural. Why am I saying this is, இந்த மாதிரி நம்பர் சிஸ்டம் பெருசாயிட்டே போயிட்டு இருக்குது. இது பார்த்தாதுன்னா இமேஜினரி நம்பர்ஸ்னு ஐன்னு கூட தனியாக வருது. இப்படி எல்லாம் வரும்போது it is quite complicated to understand. See, English numbers are worldwide, okay? And English is a word which is tedious. Example, word equations la nama when we want to express something we use words, and for example word questions la paapom. So there should be a mediator to describe using symbols. So worldwide symbols for quick and correct understanding is called sets. Sets are the standard symbols to understand in short and proceed working. Instead of writing the long sentences, sets are used. For example, in words, if you say is an element of, symbol இப்படி போட்டுக்கலாம். இப்படி போட்டால் இவ்வளோ வேர்ட்ஸை you are avoiding. They all belong to the same category or sets. இப்படி சொல்கிறதுக்கு பதில் இந்த curly brackets போட்டுட்டா முடிஞ்சு போச்சு. They don't belong அப்படின்னா இவ்வளோ வேர்ட்ஸை சொல்கிறதுக்கு பதிலாக இப்படி எவ்ரி டைம், இப்போ நீ வந்து ஒரு விஷயம் எழுதுறன்னு வச்சுக்கோ, எவ்ரி டைம் they don't belong to அப்படின்னு எழுதுறதுக்கு பதில் you can use this thing. If they all belong to, it's a curly. If they don't belong to, it's an empty set. This is called empty set. So if the number of people those belong to this class A அப்படின்னு சொல்லும்போது you should put only n of A. And when there is a universal set அப்படின்னா biggest block holding all the things, okay? அதை வந்து இந்த சிம்பிள்லையும் போடலாம், இல்லை யூன்னு சொல்லி யூனிவர்சல்னு கூட போடலாம். then the complement are a complement or a hyphen இப்படி போட்டோன்னா everything in the box of the universe, everything in the big box that is not in A. For example, இப்போ யூனிவர்சல் பெரிய பாக்ஸில் வந்து 1 2 3 4 இருக்குது, உன்னோட ஏல வந்து 1 and 2 மட்டும் இருக்குது. அப்போ ஏ காம்ப்ளிமெண்ட்னா அதுக்கு எக்ஸ்ட்ரா காம்ப்ளிமெண்ட்னா நம்ம என்ன எக்ஸ்ட்ரா கிஃப்ட் கொடுப்போம். ஸோ இல்லாத ரெண்டே நான் உனக்கு எக்ஸ்ட்ராவாக கொடுத்துருக்கேன். காம்ப்ளிமெண்ட் எக்ஸ்ட்ரா ஐட்டம்ஸ் பிகாஸ் they are not in A. Okay, so next is union intersections பற்றி படிப்போம். ஸோ union is இப்போது A union B அப்படின்னா A and B together if they are repeating they will not repeat again. For example, Aல வந்து 1 and 2 இருக்குது, Bல வந்து 1 10 and 11 இருக்குது. ஸோ A union Bல they will not write 1, 1 no, 1 2 3 4 10 and 11 அப்படின்னு தான் எழுதுவாங்க. Not only here, sets don't repeat anywhere even in the alphabets. A set of happy அப்படின்னு நம்ம எழுதணும்னா it is HAPY, it is not HAPPY. And then A intersection B அப்படின்னா ரெண்டு A and Bக்கு காமனாக இருக்கக்கூடியது. A also has one, B also has one, so A intersection B is 1. Next we talk about subset. ஸோ இதில் சப்னால இது ஸ்மால், செட்னா இட்ஸ் அ பிக். ஸோ ஒரு பிக்கில் இருக்கக்கூடிய smaller things is your subset. Everything in A is also inside the bigger B. So you are talking about the small one. So A is நம்ம subsetன்னு சொல்லும்போது we are talking about the small one. So A is having 1 and 2, B is having 1 2 3 4, we are talking about A. So A is a subset of B. சப்செட்டோட சிம்பிள்னு பார்த்தோன்னா பிக் ஒன் வந்து கீழே இருக்கும், அது மாதிரி ஸ்மால் ஒன் வந்து மேலே இருக்கும். ஸோ இஃப் இட் இஸ் நாட் அ சப்செட் நம்ம சப்செட்டோட சிம்பிளை போட்டுட்டு ஸ்ட்ரைக் பண்ணிடணும். நெக்ஸ்ட் ஒன் இஸ் set builder notation. Set builder notation you are saying the rule, not the listing exactly. For example, if A is equal to 2, 4, 6, 8 அப்படின்னா use a set notation. எப்படி போடுவோம்னா set notation you have to put a semicolon or இந்த மாதிரி ஒரு line just to say where அப்படின்னு சொல்லிட்டு x என்னது அப்படின்ற ரூலை நம்ம வந்து சொல்லுவோம். Here it is A is equal to curly leaf x where x is an even number less than 10. So it's basically written as x where x is a something அப்படின்னா ஒரு curly bracket குள்ளடி போடுறது. That is becoming a rule, not the listing of things. In maths algebra it is sets are used. எப்படின்னு சொன்னால் if x is greater than 5 அப்படின்னு சொன்னோம்னா without sets the hint for finding the answer become very vague and not precise. நம்மளோட ஆன்சர் வந்து we don't want some. For example, here உனக்கு என்ன கன்ஃபியூஷன் வரும்னா does it include all numbers, decimals are included, negative numbers are included, fractions are included அப்படின்னா நமக்கு வந்து நிறைய டவுட் வரும். அப்போ we know that n is for natural number, z for integers, q is for rational and r is for real numbers. We know with no proper hint, ஒன்றுமே hint கொடுக்கலனா no expected correct answer is obtained. But with sets we give a correct solution. We say x is an element of z, x is an integer அப்படின்னு சொல்லிடுவோம். So and then we say x is greater than 5. You can precisely say x also includes the negative numbers, but in this case it will be useful when the question is in the other way. If I am saying x is an integer and x is less than 5, when I say like this, of course you can include not only the answer on the 0 1 2 3 and all the negative numbers here in between. So now you know the difference. Otherwise நமக்கு வந்து தெரியாது where we should stop here அந்த மாதிரியெல்லாம். For example, உன்னோட requirement வந்து you're going to do an assortment packaging. So in 3 boxes I want 20 items divided by 4. So இப்படி இருக்க 3 பாக்ஸஸ் இப்படி இருக்குது, அந்த 3 பாக்ஸஸ்லேயும் 20 ஐட்டம்ஸ் இப்படி 4 அசார்ட் பண்ணி டிவைட் பண்ணி வைக்கணும். இப்போ இதோட ஈக்குவேஷன் ஆஃப் ஆன் பண்ணினா 3x is equal to 15. ஸோ இந்த எக்ஸ் வந்து எப்படி வரணும், x is 3 times 20 divided by 4. 20 divided by 4 வந்து 5 வரும். ஸோ 3 times 5 is 15 அப்படின்னு எனக்கு வந்து கிடைக்கும். ஸோ இதை நான் வந்து ஸோ என்னோடய ரிக்குவயர்மெண்ட் எக்ஸோட எக்ஸ் வந்து எப்படி இருக்கணும், இட் ஷுட் பி இன் த ஃப்ராக்ஷனல் ஃபார்மெட். ஸோ நான் செட்டில் எப்படி சொல்லுவேன், எக்ஸ் இஸ் ஈக்குவல் டு எக்ஸ் வேர் எக்ஸ் இஸ் அ ஃப்ராக்ஷன் வித் டினாமினேட்டர் 4 அப்படின்னு சொல்லுவேன். ஸோ to describe this kind of problem, sets are very helpful rather than you given a word or a word style. If you are giving your hint, it will be very confusing. So set makes it so short and sweet and little chaos.